Hello everybody, in this video I will discuss set notation, interval notation as well as function notation. Set notation. Now you will recognize something that is written in set notation by the curly brackets. This reads as the set of all x values such that x is an element of the set of real numbers and is greater than 0. There's another one. This one reads as the set of all y values such that y is a natural number, is greater than 3 and is less than or equal to 5. And there's another example. This reads as the set of all p values such that p is an integer and is less than or equal to 100. Interval notation. It is important to note that this notation can only be used to represent an interval of real numbers. Now there's an example. It's a 3 and an 11 and there's round brackets. Round brackets indicate that the number is not included. This interval includes all real numbers greater than but not equal to 3 and less than but not equal to 11. On a number line, this can be represented as, so what you do is you make a little circle, and it's a circle that's not been colored in, and then there's your 3, you make a line, and then you make a circle again, and 11. There's another interval notation. Round brackets are always used for positive and negative infinity. This interval includes all real numbers less than but not equal to -2. On a number line, this can be represented as, there's your circle, -2, and then your arrow goes to the left to indicate negative infinity. And can you see you don't color in your circle because -2 was not included. There's a round bracket. There's another interval notation, and suddenly there's a square bracket. A square bracket indicates that the number is included. This interval includes all real numbers greater than or equal to 1 because of the square bracket, and less than but not equal to 9 because of the round bracket. On a number line, this can be represented as, now suddenly you will see your circle, but it's colored in to represent the fact that there's a square bracket and the number is included. So there's your 1, there's your line, and then there's your open circle with the 9, since 9 was not included. Function notation. This is a very useful way to express a function. Another way of writing y is equal to 2x plus 1 is to write it like that. It reads as f of x is equal to 2x plus 1. That means this part over there, that is f of x. Any letter can be used, for example, g of x, h of x, b of x, etc. Now this is what I mean. In function notation, y is the output, f is the name of the function, and x is the input. Given y is equal to 2x plus 1. The value of y is dependent on the value of x. By substituting different values for x, you can obtain a set of ordered pairs, x, y. These ordered pairs represent points or coordinates on the graph of a function. This function can be represented using functional and mapping notation. Let's investigate functional notation. Now, functional notation is when you write it as f of x is equal to 2x plus 1. Here, f of x is the same as the y value. By substituting values of x into the function, a corresponding y value can be found. This results in a set of ordered pairs, and then you get your x and f of x. Therefore, this is your coordinate, this is your x coordinate, and f of x is your y coordinate. We still have y is equal to 2x plus 1. This function can also be represented using something we call mapping notation. This is written in mapping notation. This reads as f maps x onto 2x plus 1. Here, a set of ordered pairs can be obtained by substituting values of x into the function in order to find the corresponding y value. Let's discuss how to determine the output value. Given f of x is equal to 3x plus 1, find the value of the function for x is equal to minus 2 can be written as find f of minus 2. This means replace x with negative 2. So when I give you f of x is equal to 3x plus 1 and you write it as f of minus 2, this means in x's place you will substitute negative 2, and then f of minus 2 is equal to negative 5. Where does the negative 5 come from? You said 3 times negative 2 is negative 6 plus 1 is negative 5. Now, every mathematician understands that this means that when x is negative 2, the value of the function is negative 5. The ordered pair is then x f of x, or the x value is negative 2 and then f of negative 2 is the y coordinate. In other words, it's minus 2 minus 5. So all three here, this is the x and y coordinate. Let's discuss finding the input value. Given f of x is equal to 3x plus 1, find the value of x that will give a y value of 13, and this can be written as find x if f of x is equal to 13. This means replace f of x or y with 13 and then solve the equation. So you end with f of x is equal to 13, therefore 3x plus 1 is equal to 13. And now we will solve the x. So the plus 1 will walk across, it becomes negative 1. 13 minus 1 is 12. Divide away the 3. X is equal to 4. So all of that means the following. This means that when x is equal to 4, the value of the function is 13. The ordered pair or the coordinate is then x f of x the x is 4, and then f of 4 is in fact 4 and 13. So this means x coordinate, y coordinate, x coordinate, y coordinate. In the next video, I will discuss the different ways of representing functions. Click on the video in the left-hand corner to take you straight to the next lesson.